my channel. Today I gonna tell you about the main important topic in the fifth chapter of the BW, which is circuit breakers. I have already uploaded videos on the fourth chapter of the BW, which is electrical installations. Don't forget to watch that videos. If you don't find that videos, go to my channel and there is a playlist. Click on it. Otherwise, I will provide you a links in the description box. An electrical switch designed to protect an electrical circuit from damage caused by overcurrent or overload or short circuit is called circuit breaker. Now, by reading this definition, what we have understand is it is an electrical switch. Main important point is it is an electrical switch which is used to protect from what overload condition or short circuit condition. Like we use fuses now, we use fuses which save us from great damages like overload conditions and short circuit conditions. But circuits are the same type of the fuses which are a type of switches connected to the circuit to avoid overcurrent or overload or short circuit. Okay, there are so many types of circuit breakers, but the most of the main important circuit breakers are miniature circuit breakers MCB, earth leakage circuit breakers ELCB. It's also called as residual current circuit breakers, which are RCCB, and third one is air blast circuit breakers, and the fourth one is molded case circuit breakers, and the fifth one is vacuum circuit breakers, and the sixth one is SF6 circuit breakers. Today in this video, what are the main circuit breakers that we should study are miniature circuit breakers, earth leakage circuit breakers, and molded case circuit breakers. Today in this video, we will see about miniature circuit breakers. In the next videos, I will tell you about the earth leakage circuit breakers and the molded case circuit breakers. So let's start the video. Miniature circuit breakers are the electrochemical device which protect an electrical circuit from overcurrent. It's the same, its working is same like a fuse, but it works in different conditions. But the working is same for all. Okay. So what is the miniature circuit breaker actually? It is an electrochemical device. Why it is used? To protect the electrical circuits from what? Overcurrent. Okay. Next one. Designed to protect against overcurrent and over temperature faults like overheating. Sometimes our circuits or the junctions get overheated, which produce a great damage to the systems. Okay, to avoid all these conditions, we use this miniature circuit breakers. Next. Now we will see the working of the miniature circuit breakers. This is the quite simple and easy diagram to you to get identified easily. Um, this is the diagram of the MCBs, which is miniature circuit breakers. Here the orange line, which is in the form of a pole, is called the fixed contact, and the bottom box type is called the incoming terminals, and these blue lines which are formed in the form of a curve is called the moving contact, and here the brownish color line is called the plunger, and this is the operating knob, and the brownish line is called the trip lever, and here the wiring which is done on the top of the plunger is called the wire strip, and to the up left corner of the plunger outgoing terminal is present, and which is connected it to the plunger with the help of a bimetallic strip, and here the material which is made up of the plunger is solenoid, and this is all about the part of the MCBs. Now we will see the detailed working of the MCBs. The two main components of the MCBs are magnetic coil and bimetallic strip. Okay. in the working of the MCBs, which you should remember the two main components of your component, which is the magnetic coil and the bimetallic strip. Why do we use a magnetic coil? Why do we use bimetallic strip? In which case we will use them is magnetic coil is an electromagnet attached by plunger. We can see here it is a magnetic coil. It is a magnetic coil attached to the plunger. This brownish line is called the plunger, and this square-faced surface is called the magnetic coil. Okay. Bimetallic strip is made up of two metal compositions. What are those metal compositions? Why do we use them? Let's see. When more current flows through the bimetallic strip than the range of the MCBs, then it bends. Bimetallic strip is actually in this form. When the overcurrent passes, that is fuses, then it bends to curves. Okay. Okay. Bimetallic strip plays a main role in the tripping mechanism. What is meant by tripping mechanism is its tripping mechanism means like fusing. When overcurrent passes, it trips, means it fuses. Okay. For tripping, two mechanisms are used. For tripping means to fuse off or to off the supply. The two mechanisms are used in them. The first one is magnetic coil. During short circuit fault trip MCB, we use magnetic coil, whereas overload trip MCB, we use bimetallic strip. The work is tripping lever is to separate fixed contact and the moving contact to trip MCB. What is the main importance of the trip lever is trip lever will separate the fixed contact and the moving contact. Why do we separate the fixed contact and moving contact is to stop the circuit. Here you can see this is the fixed contact and this is the moving contact. These both are separated to reduce the tripping mechanism. This is in the form which we will open the circuit. Here, the next point is on the both sides, terminal port is placed to connect MCB. Terminal connections are given on the both sides of the MCB to connect it. Next, triggering lever and bimetallic strip are coupled together. So bimetallic strip when bends, then trigger lever separated a moving contact and fixed contact. As we have said that a triggering lever is connected to both the moving contact and the fixed contact, and here triggering lever is coupled with the bimetallic strip. We have already said that during overload condition bimetallic strip bends. When the bimetallic strip bends automatically as triggering lever is coupled with the bimetallic strip, it also uh, do some work. What's that work? It separates moving contact and the fixed contact. Okay, this is the direction of the current flow. See next. Terminal from the terminal port, it goes to the magnetic coil, and from magnetic coil, it again goes to the fixed contact, then to moving contact, then to bimetallic strip, and then finally to the another terminal port. This is the flow of the current. Next, there are two conditions as we have discussed above. One is overload condition, another one is short circuit condition. What we have said is when overload condition, fixed contact and moving contact separate from each other. We know that the bimetallic strip and the triggering lever are in contact coupled with each other. As the bimetallic strip bends, then the triggering lever also separates the moving contact and the fixed contact that we have discussed above. Now, when short circuit condition, plunger hit the triggering lever and fuses close the circuit. What is meant by the plunger? Let's see. This rod type line is called a plunger. It when short circuit condition it just hits the this magnetic coil with the force which stops the circuit to flow the current. The main applications of the MCBs are they used to protect lights, fans, and heaters, etc. This is all about the MCBs. I have already uploaded videos on the fourth chapter of the BW, which is electrical installations. If you want more videos, I have please subscribe to my channel and don't forget to click the bell icon to get notified to my videos. I have already uploaded so many videos, so don't forget to watch them and click the bell icon without forgetting. Thank you.